In this explainer, we're going to pull back the curtain on one of machine learning's most fundamental algorithms, linear regression. We'll walk through a complete Python project, breaking down the code line by line so you can see exactly how it all works.
Today, we are going to understand the complete linear regression code step by step. We will see what each part of the code does, why it is used, and how it helps in building a linear regression model.
So, to make this a bit more real, let's frame our project with a question. Can just a few lines of code actually predict a student's starting salary based only on their college grades? That's exactly the problem we're going to solve today. Let's dive in.
All right. Every single machine learning project, no matter how complicated it seems, always starts with the same two things: getting your tools ready and getting your data loaded. Let's see exactly what that looks like in the code.
The very first thing you'll almost always see at the top of a Python script for data science is this: importing our libraries. You can think of this as laying out all our tools on the workbench before we start building anything. Let's quickly go over what these three tools are for.
So why these three in particular? Well, Pandas is our go-to for handling data. It lets us load our data set and work with it in a nice, clean table, kind of like a super-powered spreadsheet. NumPy is our math workhorse. It's essential for all the heavy-duty number crunching. And finally, Matplotlib is our artist. It's what we'll use to draw charts and actually see how well our model did at the end.
With our tools all set, we can now load our data. This line you see here uses Pandas to read a file called placement.csv and store all of its contents in a variable we're calling df, which is just a common shorthand for data frame. This is the moment our raw data officially enters our program.
Now, before we start doing anything fancy, it's always a good habit to just take a quick peek at the data we just loaded. The .head function is perfect for this. It just shows us the first few rows so we can make sure everything loaded correctly and see what our columns are called. In this case, things like CGPA and package. It's a really important sanity check.
Okay, our data is in. The next step is to structure our problem so the machine learning model can understand it. This really just means we need to be crystal clear about what information the model can use and what it's supposed to predict.
So here, what we're doing is splitting our data into two very important parts. We're creating a variable called x, which will be our input, or our feature. For us, that's the student's CGPA. Then we create y, which will be our output or our target. That's the thing we want to predict, the salary package. And this whole idea of x and y is totally fundamental to machine learning. The goal is almost always to predict some target value y, based on some input features x. So we're telling our model, look at the CGPA, which is x, and learn how to predict the salary package, which is y. Now, this next line of code you see here, this is one of the most important steps for building a model that we can actually trust. We use this function called train test split to chop our data set into two separate piles, a training set and a testing set. So why would we do this? Why hide some of our precious data from the model? Well, think of it like this. The training data is the textbook our model gets to study. It can see both the CGPAs and the matching salaries, so it can learn the pattern. The testing data, on the other hand, is like the final exam. We only show the model the CGPAs from this set, and we ask it to predict the salaries it's never ever seen before. This is how we check if it actually learned the pattern, or if it just memorized the answers from the book.
Okay, we've done all the prep work, we've got our data ready and split up. Now we get to the heart of it all. It's time to create our model and actually train it.
This very simple line of code is where we create an instance of the linear regression model. Right now, our variable LR is basically an empty brain. It's ready to learn, but it doesn't know anything at all about our student placement data yet. And what is it ready to learn? Its entire purpose in life is to find the one perfect straight line, that classic y equals mx plus c from math class that best represents the relationship between our x and y values, between CGPA and salary. And this is the magic moment. The .fit method is where all the learning happens. We're passing it our training data, both the questions, which is our x underscore train, and the answers, our y underscore train, and we're telling it, okay, go figure it out.
So what is .fit actually doing behind the scenes? Well, first, it observes all the CGPA and salary pairs in our training data. Then, it does the math to calculate the perfect slope m and intercept c for a line that gets as close as possible to all those data points. Once it finds those two values, it saves them. The model has now officially learned the relationship. Our model has finished its training. Now for the really exciting part, let's put it to the test, see what it can predict, and then grade its performance to see how well it actually did.
Because the model is now trained, we can use the .predict method to ask it for a prediction. We can give it any new CGPA value, like the ones from our test set that it's never seen, and it will use the M and C it learned to calculate a predicted salary package.
Making predictions is great, but we have to ask, are they any good? We need to evaluate the model's performance to know for sure. And a really common way to do this for regression is to calculate something called the R-squared score.
The R-squared score is just a number between 0 and 1 that basically acts like a report card for our model. A score of 0.78 is like getting a 78%, which is pretty good. It tells us that our model can explain about 78% of the differences in student salaries just by looking at their CGPA. For such a simple model, that's actually quite powerful.
Numbers are great, but sometimes a picture tells a much better story. So for our final step, we're going to use matplotlib to visualize our results. We'll plot all the real data points, and then we'll draw our model's prediction line right on top to see how they compare.
And here it is. This chart really shows us everything. Each one of those blue stars is a real student from our data, with their actual CGPA and salary. And that red line, that's the single best fit line our linear regression model found. You can see how it slices right through the middle of that cloud of data points. That's exactly what we wanted to see. It means our model successfully captured the general trend.
Now you clearly understand how linear regression code works and why each part is important. In the next video, we'll move to more advanced regression concepts.